Let's take a look at some sample problems from section 4.4 on conversion between number bases. In the textbook, you'll want to turn to page 165, and we'll begin with number 2. It says, list the first 20 counting numbers in each base, and 8 is the base that we're to use. Okay, they're doing counting numbers, so they don't actually start with 0, but I'm going to start with 0. Let's see. Yeah, they write out the word. Let me do that since that's the way the book does it. Two, 3, 4. We only can go up through, use up through symbol 7. 8, 6, and 7. Okay, so we've counted 1 through 7. I added 0 in just to keep my columns straight. 8 is going to be 1, 8, and 0 ones. So 9 would be 1, 8, and 1, 1. 10 is going to be 1, 8, and 2 ones. And you can see the pattern. Now I usually just, once I see what's happening, I go ahead and just fill them in. I check them when I move to a new row to see if it makes sense. Okay, we have 1, 8, and 7 ones. So that would be 15. 16 would be 2 8s and 0 ones. So this is 16. This would be 17. We're getting close. 18. 19. And 20. So that's 2 8s, which is 16, plus 4 1s would give us 20. Okay, so that one is one of the tougher ones that you'll have to do. Okay, let's go to number 6. Write in the same base the counting number before, just before, and just after the given number. Do not convert to base 10. So we have 555 in base 6. Okay, the one before is easy enough. All we have to do is subtract 1 from the ones position. So that's the one before. And then for the one after, we have to add a 1. Now remember, in base 6, anytime you add to get a 6, that becomes a 1 0. In base 6, 6 is written 1 0, base 6. So we get a 6, we get a 6 again, we get a 6 again. So this is the one after. That's a little bit tricky, but that's the before and the after. Okay, in number 8, we're doing another one the same way. 1 0 1 1 1. This is base 2. So the one before, we'd want to subtract 1, and that would leave us with a 0. So that'll be the one before. And then again, we want to add 1 to figure out the one after. Again, in base 2, anytime we add to get a 2, remember we write 2, 1 0. It's 1 2 and 0 ones. So we get a 2, we get a 2, we get a 2. 1 plus 0 is 1, and 1 plus nothing is 1. So this is the one after. Okay, so I think probably these three questions are some of the hardest once you get the concept down. They're not too awfully difficult, but it is hard at first. Okay, now we have a couple of really easy ones. It says determine the number of distinct symbols needed in each of the following positional systems. Base 7, we need 7. Base 16, we need 16. So very easy and straightforward. Next one, determine in each base the least and the greatest 4-digit numbers and their decimal equivalents. Okay, the least 4-digit, it can't start with a 0, so it would have to start with a 1, but zeros would be the smallest numbers. Okay, so that's 16 to 0. I'm just going to put these up above, 16 cubed. So that's 1 times 16 cubed, which is, I never can keep base 16 in my head. 16 cubed is 4,096. So that's the smallest number, 4-digit number we can write in base 16. The largest one, if we look at our table for base 16, alright, on page 164, base 16, the highest symbol we have, which is equivalent to 15, is an F. Sounds like a bad report card. Okay, so we'd have to have F's in all 4 positions. Again, a bad report card. So that's going to be 15 times 16 cubed plus 15 times 16 squared plus 15 times 16 plus 15 times 1, or 16 to the 0, which would be a 1. Alright, I'm using a calculator to do this. 15 times 16 raised to the 3rd plus 15 times 16 squared plus 15 times 16 plus 15. I got 65,535. Okay, so our smallest 4-digit number in base 16 is 4,096. And our largest one is 65,535. All right, now we get into the conversion between other bases at base 10. And directions say convert each number to decimal form by expanding in powers and by using the calculator shortcut. Cross off, don't do anything with the calculator shortcut. I find it very confusing. So I figure if it's confusing for me, it would be much worse for students. Just go ahead and use expanding the powers. To me, that's the simplest and most straightforward way to do these. So we have 6-2 base 7. So just reminding myself what these positions mean. So we have 6 times 7. Plus 2 times 7 to the 0 is 1. 42 plus 2 is 44. Okay, and number 20, we have 3, 4, 4, 3, 2. Base 5, 3, 4, 4, 3, 2 in base 5. So 5 to the 0, 5 to the 1, 5 squared, 5 cubed, 5 to the 4th. And so that's 3 times 5 to the 4th plus 4 times 5 cubed plus 4 times 5 squared plus 3 times 5 plus 2 times 1. Okay, and 3 times 5 raised to the 4th, plus 4 times 5 raised to the 3rd, plus 4 times 5 squared, plus 3 times 5, plus 2 times 1. I get 2492 would be the base 10 equivalent. Okay, 24, we have A, B, C, D at base 16. I know it looks strange, a number with letters in it. Okay, so A represents 10, B represents 11, C 12, and D 13. And each of these is a power, the position represents a power of 16. So we have 10 times 16 cubed plus 11 times 16 squared plus 12 times 16 plus D is 13 times 1. Alright, so 10 times 16 cubed plus 11 times 16 squared plus 12 times 16 plus 13 times 1. Okay, I came up with 43,981. Okay, that looks correct for that one. Okay, so that's going from another base into base 10. We want to expand by powers of that base that were given in the problem.